In this video, we're going to go over the law of reflection and the law of refraction. So let's say if this line represents the boundary between two materials. Above we have air, and let's say below is glass. And this vertical line, which is perpendicular to the surface, it forms a 90-degree angle with the surface. This is called the normal line. And let's say if we have a light ray that is incident on this boundary. The incident ray is the ray that strikes the glass. And this is called the reflected ray. I gotta make it equal. So this angle between the incident ray and the normal line, this is called the angle of incidence. This angle between the normal line and the reflected ray, that's the angle of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. So if the angle of incidence is 30 degrees, the angle of reflection will also be 30 degrees. That's the law of reflection. Refraction is the process where light bends as it passes through the air-glass boundary. So this ray represents the refracted ray. And this angle inside is the angle of refraction. It's between the refracted ray and the normal line. So whenever light strikes the boundary between two materials, it can reflect or it can refract. And just remember, refraction is the bending of light as it passes from one material to another. Now there's something called the index of refraction, and it measures how much light bends as it passes from one material to another. The index of refraction for air is about 1. The index of refraction for glass is roughly about 1.5. So notice that the light ray travels from a low end value to a high end value. As light moves from a low index of refraction to a material with a high index of refraction, the light ray is going to bend closer to the normal line. Therefore, the angle of refraction is going to be less than 30 because it's going to bend closer to the normal line. And we can calculate that angle using Snell's law of refraction. The equation that we need is n1 sine theta 1 is equal to n2 sine theta 2. So let's say 1 is for air, 2 is for the glass. So n1 is 1 times sine of 30, which equals n2, which is 1.5, times sine theta 2. Now, it turns out that sine 30 is 0.5. So to solve for sine theta 2, you need to divide by 1.5. So sine theta 2 is 0.5 divided by 1.5. That's basically a third. That's 0.333 repeating. Now to find theta 2, what you need to do is take the inverse sine of both sides. Theta 2 is the inverse sine of 1/3, or 0.333. And make sure your calculator is in degree mode, not in radian mode, because mine was in radian mode. So the angle that I got is 19.45, which I'm going to say about 19.5 degrees. So as you can see, it's less than 30. So whenever light goes from a low end value to a high end value, as it moves from one material to another, the light ray is going to bend closer to the normal line. Now, if light were to go from a material with a high index of refraction to a low index of refraction. So let's say if we were to go backwards, the light ray would bend away from the normal line. The angle will increase. So as the index of refraction of a material increases, the angle decreases, meaning that the light ray it moves closer to the normal line. Now, another thing that you may need to calculate is the speed of light in a material. The speed of light in a vacuum or empty space is 3 times 10 to the 8 meters per second. But when light travels, let's say in water or in glass or in diamond, will the speed of light increase or decrease? It turns out that light, it decreases in speed when it moves in a different material. Light travels slower in water than in empty space because there's more molecules in water that it has to get through. There's an equation that can help you to calculate the speed of light in a material. It's V, which is equal to C over N. So if you want to find the speed of light, let's say in water, it's going to be the speed of light in a vacuum, which is 3 times 10 to the 8, divided by the index of refraction of water, which is about 1.33. So therefore, the speed of light in water is about 2.26 times 10 to the 8 meters per second. Now, the speed of light is not the only thing that changes. The wavelength of light changes whenever light passes through a different material. As the index of refraction increases, the velocity of light decreases. So as you can see, light travels slower in water than in empty space. Also, the wavelength decreases as well. So here's an equation that relates wavelength with the index of refraction. Wavelength 2 divided by wavelength 1 is equal to n1 over n2. They're inversely related. Now, let's say 1 is for air and 2 is for the new material. So this is going to be wavelength 2 divided by wavelength 1, and the index of refraction of air is 1 over n2. So I'm going to multiply both sides by wavelength 1. So these are going to cancel. So then you're going to get this equation. Wavelength 2 is equal to wavelength 1 divided by n2. In most textbooks, this equation is going to look like this. Wavelength n is equal to wavelength naught divided by n. This is the equation that you want to know, as well as this one too. You should add those two equations to your list of equations, or if you have a formula sheet. So what this equation says, the wavelength of light in a vacuum divided by the index of refraction of a different material is equal to the wavelength of that material. So let me give you an example problem. Let's say if the wavelength of light in a vacuum is 500 nanometers. What is the wavelength of light in glass? So all we have to do is use this equation. The wavelength of light in a material is equal to the wavelength in a vacuum divided by the index of refraction of that material. So the wavelength of this light is naturally 500 nanometers. But we want to find the wavelength in glass. The index of refraction of glass is about 1.5. So 500 divided by 1.5 is about 333.3 nanometers. So this is the wavelength inside of glass. So as you can see, when light travels to a material that has a higher index of refraction, as n goes up, the wavelength of light will decrease and the speed of light will decrease. However, the frequency will remain the same. By the way, the frequency of light, you can calculate it using this equation. C is the speed of light, lambda is the wavelength, and F is the frequency. Some textbooks might use V as the frequency, but I'm going to use F because in physics, V represents velocity, but in chemistry, V could be frequency. Now, this equation is for a vacuum. In a different material, you might see this equation. So V is just the velocity of light, or the speed of light, in a different material other than a vacuum. And lambda is the wavelength of light in that material. So let's calculate the frequency using the information that we had in the last example. So the speed of light in a vacuum is 3 times 10 to the 8. The wavelength was 500 nanometers, which is 500 times 10 to the negative 9 meters. If you're going to plug in the wavelength data into the equation, make sure you put it in meters because the speed of light is in meters per second. So we can solve for F. So it's 3 times 10 to the 8 divided by 500 times 10 to the negative 9. And F is 6 times 10 to the 14 hertz. The unit hertz is the same as 1 over seconds, or s to the minus 1. Now let's calculate the frequency using this equation. So the wavelength for that equation was 333.3. This is in glass. We want to find the frequency in glass. Using this equation, we found the frequency of the light in a vacuum or in air. Now we got to find the velocity or the speed of light in glass using this equation. V is equal to C over N. So that's 3 times 10 to the 8 divided by 1.5. 3 divided by 1.5 is 2, so this is 2 times 10 to the 8. So we're going to plug in this value for V and lambda, and we're going to see if we're going to get the same answer, 6 times 10 to the 14. So 2 times 10 to the 8 is equal to, make sure you convert lambda into meters. So it's 333.3, and just add 10 to the negative 9 meters. 1 nanometer is 10 to the minus 9 meters. So let's solve for F. So 2 times 10 to the 8 divided by 333.3 times 10 to the negative 9. You should get the same answer. So F is 6 times 10 to the 14 hertz. So as you can see, the frequency of light does not depend on N. As light moves from, let's say, air to glass, the frequency remains the same. The wavelength and the speed of light decreases, but the frequency is constant. Now, there's some other things that we need to go over, and that is the difference between diffuse reflection and specular reflection. Diffuse reflection occurs on a rough surface, let's say like a polished wooden table, and specular reflection occurs on a smooth surface like a mirror. In diffuse reflection, light is scattered along the rough surface, and so it's going to bounce off in different angles, and so that's why you won't see your image clearly. If you have a polished table, you can somewhat see your image, but not very clear. So in such a situation, diffuse reflection is occurring. Now in the case of specular reflection, you can clearly see your image, as in the case of a mirror. Because the surface is smooth, light is not scattered at that surface. It reflects in the same direction. And so make sure you understand the difference between diffuse reflection and specular reflection, because sometimes you might be tested on this concept. Now let's work on a few practice problems. So let's say this is the first mirror and we have another mirror. I'm going to call this M1, M2. And in addition, we have a light ray that strikes the mirror at a 30-degree angle. And then this light ray, it bounces off and strikes this mirror. And you want to find the angle at which the light ray leaves the second mirror. So what is the angle theta? And let's say that the angle between the two mirrors is 110 degrees. Feel free to pause the video and solve the problem, and then unpause it when you're ready to see the solution. So what's the first thing that we need to do to solve this problem? Well, let's find this angle. Let's draw the normal line, which is perpendicular to the surface. And so here we have another normal line. So if this angle is 30, this angle must be 60. It's complementary. They have to add up to 90. And according to the law of reflection, the angle of incidence, which is 60, must equal the angle of reflection. So this side is 62, which means this is 30. Now the three angles in a triangle must add up to 180. So 180 minus 110 minus 30, that's 40. So the missing angle is 40, which means that this angle is 50, and according to the law of reflection, this angle must be 50 as well, which means that theta is 40. So using the law of reflection, you can easily find this angle. Let's try another problem. So let's draw the picture first. So let's say this material is air, and then we have glass, and finally diamond. Now let's say that light strikes the boundary between air and glass at a large angle of 60 degrees. And then it refracts into glass. And then afterward is going to refract into diamond. So what is the angle theta at which it enters into the diamond material? How can we find that angle? Feel free to pause the video and try it. By the way, the index of refraction for air is 1. For glass, it's about 1.5. And for diamond, it's about 2.4. So let's solve for theta 1. Or let's call it theta 2. Let's say theta 1 is 60. So using Snell's law, n1 sine theta 1 is equal to n2 sine theta 2. So n1 is 1, and then we have sine 60, which is equal to n2, that's the value for glass, times sine theta 2. So let's solve for sine theta 2. Sine theta 2 will be equal to sine 60 divided by 1.5. If you type that in the calculator, you should get root 3 over 3, which is about 0.577. So theta 2 is the inverse sine of 0.577. So you should get 35.26 for the angle. So now let's solve for theta 3. So we need to use Snell's law again. So using the equation n2 sine theta 2 is equal to n3 sine theta 3. So the second index of refraction for glass is 1.5 times sine theta 2, which is 35.26, and that's equal to n3, which is 2.4 times sine theta 3. So sine theta 3 is going to be 1.5 times sine 35.26 divided by 2.4. And so this is equal to 0.36. And the inverse sine of that answer is 21.1 degrees. So that's the value of theta 3. So notice that the angle between the normal line and the ray, it decreases as n increases. So here we have a small value of n, but the angle is very large. And as n increases, the angle decreases. Here n is very high, but the angle is the smallest of the three. By the way, another way in which we could find theta 3 directly is, instead of saying n1 sine theta 1 equals n2 sine theta 2, we could say that n1 sine theta 1 is equal to n3 sine theta 3. So let's say if you only want to find this angle, and you really don't need to find theta 2, you can go directly to theta 3 by using just air and diamond. You can skip glass. So let's try it that way. So n1 is 1 and theta 1 is 60. n3 is 2.4, and let's solve for theta 3. So sine 60 divided by 2.4, that's 0.3608. And theta 3 is going to be the inverse sine of 0.3608, and you get about the same answer, which is 21.1 degrees. So even if you have multiple materials, if you need to find the last angle, you can simply go directly to that angle using the first one. So let's say if we have multiple materials. Let's say on top it's air, and then we have water, and then it's glass, and then let's say plastic, and diamond at the very end. So let's say light strikes the surface at a 70-degree angle, and then it refracts into these surfaces. So what is this angle? Let's just call it theta. How can we figure it out? So even though we have multiple materials in between, all we need to focus on is the first part and the last part, air and diamond. The index of refraction of air is 1. The index of refraction of diamond is about 2.4. And so that's all we need. So in this case, we could say n1 sine theta 1 is equal to n5 sine theta 5. So 1 times sine 70 is equal to 2.4 times, we'll just call it sine theta. Sine 70 divided by 2.4, that's 0.3915. So to solve for theta, we need to use the inverse sine function. So inverse sine of 0.3915, that's about 23 degrees. And so even though you have multiple layers of different material, you just need to focus on one material, the one that you have the information for, and the one that you're looking for. So if we want to find the index of refraction or the angle for, let's say, glass, we could just use air and glass. We can skip water. We can find the angle for any one of these if we just focus on that material only. Let's try another problem. Let's say that this is a block of material and the index of refraction is 1.2. And outside we have air, which has an index of refraction of 1. Now let's say light strikes this boundary at an 80-degree angle, and then it refracts into the material, and then it escapes back out into air. What is the angle theta? Go ahead, pause the video, and see if you can get the answer. So let's use Snell's law to find theta 2 first. So n1 sine theta 1 is equal to n2 sine theta 2. n1 is 1 for air, and the angle outside is 80. n2, that's going to be 1.2 times sine theta 2. So sine 80 divided by 1.2, that's about 0.8207, and that's equal to sine theta 2. So theta 2, therefore, is the inverse sine of 0.8207. So therefore, theta 2 is about 55.2 degrees. Now notice that we can turn this into a right triangle. And so this is 90 degrees. To find the other angle, it's going to be 90 minus 55.2. And so this angle here is about 34.8 degrees. So now we could find this angle, which we'll call theta 3. So n2 sine theta 2 is equal to n3 sine theta 3, where theta 2 is a different angle. It's 34.8 instead of 55.2. So n2, that's the index of refraction for the material. That's going to be 1.2 times sine of 34.8. That's equal to n3, which is associated with air, which has an index of refraction of 1, times sine theta 3. So 1.2 times sine 34.8, that's going to be about 0.6849, and that's equal to sine theta 3. So theta 3 is the inverse sine of 0.6849. And so the final answer for this problem should be about 43.2 degrees. So that's the angle at which light is going to emerge out of this material and on the other side. Try this problem. The speed of light in ice is 2.3 times 10 to the 8 meters per second. What is the index of refraction of ice? So the equation that we need for this problem is V is equal to C divided by N. We have V, that's the speed of light in a different material, and N is the index of refraction of that material. C is the speed of light in a vacuum. So you got to solve for N. So let's rearrange the equation. Let's cross multiply. 1 times C is C, and V times N, that's just Vn. And then if we divide by V, the index of refraction is the speed of light divided by, it's the speed of light in a vacuum divided by the speed of light in the material. So it's going to be 3 times 10 to the 8 divided by 2.3 times 10 to the 8. We can cancel the 10 to the 8s. So all we need to figure out is the value of 3 divided by 2.3. And so it's about 1.3. So that's the index of refraction for ice. As you can see, It's very similar to water, which is 1.33. A certain light ray has a wavelength of 400 nanometers in glass. What is the wavelength of this light in diamond? What equation do we need for this problem? So, if you have one wavelength and you want to find another, you can use this equation. Lambda 1 divided by lambda 2 is equal to n2 over n1. So let's say lambda 1 is 400 nanometers. We're looking for lambda 2. Now, lambda 1 corresponds to n1. So the 400 nanometers, that wavelength is associated with glass, and the index of refraction for glass is 1.5. The index of refraction for diamond, which is associated with n2, that's about 2.4. So now all we need to do is solve for lambda 2. That's the wavelength of light in diamond. So let's cross multiply. So it's going to be 2.4 times lambda 2, and that's equal to 400 times 1.5. What's 400 times 1.5? 400 times 1 is 400. 400 times 0.5, or half of 400, is 200. If you add 400 and 200, you're going to get 600. Now we just need to divide both sides by 2.4. So 600 divided by 2.4, that's about 250. So because diamond has a higher index of refraction than glass, the wavelength in diamond is going to be lower than that in glass. It's going to be less. But this is the answer. So you just need to use this equation. So that is it for this video. Thanks for watching and have a great day.